Hello, this is Mark Cruz, and I am doing rigor mortis and dead fish and raw chicken. So the question is, what is rigor mortis? Well, rigor mortis is technically just the stiffening of the body, and this can happen in many reasons. It usually can take a place from anywhere from 2 to 4 hours, but depending on the conditions, it could take up to 12 hours, up to 24 hours for it to activate, and it can even activate within 2 hours and end within 6 hours. So there's a lot of variables that can affect rigor mortis. The way how rigor mortis starts is pretty much when somebody dies, their body has a lack of ATP, like as the death goes on, which causes the myosin heads to stay connected to the actin, which causes stiffness. So then when the body decomposes, decay starts. So then the body starts to, decay, and then that's when it goes from stiff, more limp again. So here, for example, you can see where the myosin head attaches to the myofilament. That's the myosin connected to the actin. And then in step 2, this is the important role. You see the ADP connect. This is called the power strokes. The power stroke will pull, which will lock up. So then once it locks up, it's tense and it's contracted. Now, the only issue with this is with the ATP, the more dead the body is, and the more exerted the person was before they died, there's no ATP to actually reset the myosin head. So that is a major issue when it comes to rigor mortis. But then that's also the way it stops, is because once there's no more ATP, it locks up, and then after decay. Yes, and with rigor mortis, the other issue is the calcium ion pump. There's no ATP to activate the calcium ion pump and put it back into the sarcolemma reticulum. So as you can see in the example, I think you can see my cursor right here, the little yellow dots on this line, which we call the key, or the troponin, it will actually take it off of the actin, and that's what causes the myosin head to be able to connect. So this could be stopped if the calcium could leave, but since there's no ATP to activate the pumps, to put the calcium back into the reticulum, it will just keep connecting and it will just stay. Factors that affect rigor mortis. The cold. The cold has been known to pretty much lengthen rigor mortis. It can slow down most decompositions and pretty much like elongate the time that rigor mortis will start. So with rigor mortis, there's pretty much no decay in the cold because the body is being kept at usually a frozen temperature or a colder temperature. So the heat, there's not a lot of heat to radiate and make the energy move faster. So it sort of slows the process. So this can create a longer rigor mortis when the rigor mortis is activated. The other thing too is if the body is completely frozen, it has to be partially thawed in order for it to work. Because obviously, when you're frozen, our bodies are about 70% water. You're stiff anyways. And just like with the heat, if there's a struggle beforehand, then there would probably be less energy. So even though it's elongated, it could take more time, it would be lengthened still. But if you compare hot to cold or even normal, the cold will still be longer, but it won't be as long as other versions of cold rigor mortis. Heat. Muy calor. Heat quickens the effect of rigor mortis. So rigor mortis in the heat pretty much gets rid of the ATP faster because you're having a lack of energy. So usually it's when people are hot, overstimulated, like running, and then out of nowhere, the body just drops. Could be heat stroke, it could be being stabbed after going for a run. It could be dying to super hot temperature. So the body usually with heat dies quick and loses a lack of energy. So this causes rigor mortis to happen quicker, but then it also ends faster too, because there's a lack of energy, and then with the heat too, your body will decay faster. Yeah, so this is actually a photo I want to go back to. So this gentleman right here, he had rigor mortis. I found this photo, and I know it's a little unethical to an extent, but it fascinated me. I looked at it and I said, this is sort of wrong, but at the same time too, I'm like, it's interesting because most people can't even do that, even the biggest athletes and the most strong athletes. But with rigor mortis, the body is completely stiff, and the person probably died either laying in bed or it was probably laying on bed just because of the depth and the curvature of the back and like with how the legs are straight. But you can see even his arms got stuck up high. And this man or woman put this man right here across two tables, and he's perfectly held up. So I found that quite fascinating. So here is an example of raw chicken and dead fish moving, and there's a good reasoning for this. Same thing with reptiles; it can happen to them as well. The spinal cord is usually still connected. Same thing with the ribs, so it's still innervated. So the ribs and the like backbone will send electrical impulses, which can actually start NMJ, which can start the process. And since it's still ATP because it's sending the neurons down with the energy, it can actually do the calcium ion pumps. So what will happen is it will activate it, stop it, activate it, stop it, activate it, stop it. So that's why you get that movement. So the animal is dead, obviously, but it looks like it's alive because it's getting those primal impulses. But it is quite a fascinating video. And I actually, before I watched this one, I didn't even realize, as you can see, amphibians and reptiles as well count in this category. There's snake somewhere right here. That freaked me out for a minute. But that's how it works. And then same thing too is if you're skinny and have a leaner muscle mass with lower fat, the rigor mortis will take effect faster because with fat people and people with higher fat content, they actually have enough body fat to preserve and to hold ATP, which will use the energy to keep the body loose, like contracting, contract for a longer period. So it takes longer for a fatter person to reach rigor mortis than for a skinnier person. But thank you for watching my video, and I appreciate it. This is Mark Cruz, and I am signing off.